How do you go about your daily business when you don't know how to do integration by substitution? Let's go. So we use integration by substitution when we want to simplify an integral further using another variable. We'll call it u in this video, for example. Okay, I've put the integral x over x plus 2 all squared dx in front of you. Try and integrate it. Let's set u is equal to x plus 2. That'll simplify things. Okay, then what we need to do is we need to differentiate on both sides. So du is equal to 1 dx, okay, because we need to find dx, because that's the form of every integral of y dx. Okay, now we found dx. We rearrange to make x the subject. X is equal to u minus 2, because we need to rephrase this integral in terms of u. Okay, so now we get integral of u minus 2 over u squared, because remember, the u was equal to x plus 2, we made it, so we've squared it, and now it's equal to u squared. Now we separate out the numerator, and we can do that because the denominator is only one term. Integral of u over u squared minus 2 over u squared du, and because dx is du, we can substitute in du. Right. Then we can factor out, then we can write that as integral of 1 over u minus 2u to the negative 2 du. And then obviously 1 over u integrates to ln u. And when we add 1 to the power in minus 2u to the negative 2, we get negative 1. And negative 2 divided by negative 1 is positive 2. So the answer is ln u plus 2u to the negative 1 plus c. And then we sub in our u for x plus 2, and then we get that answer. Okay, that's pretty simple. Let's bump up the intensity a notch. Okay, now we've got the integral 1 over x brackets ln x all squared dx. How do we do that? Right, we need to assign a u. Let's make it ln x, because that's the most logical thing to do, because the ln x is the only thing that's really making our integral complicated in this scenario. Okay, u is ln x. We differentiate. Du is equal to 1 over x dx. We need to make dx a subject, remember? So we need to make it x du is equal to dx, okay? So we know that x du is equal to dx, so we can sub it in later on. Now, we can write this. What do we know? We know ln x is equal to u. So we can rewrite this integral as 1 over x u squared. Don't worry about the x. And then we times it by x du. Now, because we times it by x du, we're getting rid of the x, so it cancels out. So you don't need to worry about it. Not everything needs to be written in the form of u, because other terms can cancel out after you've differentiated the u term. Okay, then you can write it as integral of 1 over u squared du. That's just integral of u to the negative 2 du, which is equal to negative u to the negative 1 plus c. And we sub in u as ln x, so we get negative 1 over ln x plus c. And that, ladies and gentlemen, is how you do integration by substitution.